Good afternoon, everybody. Good afternoon, Internet. Good afternoon, YouTube. Back with some more lunchtime study. Today we are going to be working for the first time with ACLs, access control lists, filtering traffic to different parts of our network, and that's pretty exciting. So what we're going to be working on is day 34 of Jeremy IT Labs CCNA prep playlist. And as you can see, the networks start to get a little bit more complicated, which is kind of cool. I haven't worked with ACLs much as part of this course. And in fact, this prompted me to go and look more closely at a lot of the web ACLs that we have configured at work to limit traffic from one VPC, for example, to another. And so this is kind of a refresher on all that and solidifies some of the learning that I've done previously. And so here we are, first time going through this. Let's see how it goes. Step 1. Configure OSPF on R1 and R2 to allow full connectivity between the PCs and the servers. All right, so let's just first confirm that, for example, PC 1 cannot ping server 2, 192.168.2.100. Let's try that just to verify that we are not in a working state. And I would like to actually increase. I'm going to do file, what is it, properties, preferences. I want the text to be bigger for this stuff because I just don't feel like it is. 18, okay, so that's the application. I don't actually want to increase that too much, but for the CLI, I'm going to go up to 20. How about that? Apply. Okay, and then we get to the CLIs. A little bit bigger, a little bit better, hopefully. All right, so what did we say? We want to ping 192.168.2.100. And I would expect this to fail because we don't have a route to that subnet. And now we're going to configure OSPF on router 1 and router 2 such that the devices on the network dynamically learn routes to different subnets. All right, so router 1. Let's work on that. All right, so for enabling OSPF, we do en conf t, and I want to say router OSPF, process ID 0 for the backbone. Actually, is that right? I'm going to say 1 for the process ID. Yes. Okay. So we have that going, and then we need to enable sharing of routes for some different networks. So it looks like on router 1 we've got the serial network, the 203 subnet. And then we've got the 172.16 and the 172.16 up here. So I think we'll do a /16 wildcard mask to encompass both of those. Network 172.16.0.0. And then we'll do 0.0.255.255, which is the wildcard mask to enable, to allow those. Area, and then the backbone area is typically 0. And since there's only one area, that makes sense. Okay. And so that should cover the first two subnets, 172 on the G00 and 172 on the G01. Now we need to do network 203.0, 113.0. All right, and that's for the serial network on the serial port here, S000. And the wildcard for this will be a /24, also area 0. And then I think that should be it for that one. I don't think there's any other steps, but I'll find out in a moment. All right, let's do the same on R2. So we get over to R2 and en-conf t router OSPF process ID 1. All right, and then we are in OSPF configuration mode. And we'll do the same thing. So similar setup here. There's a serial port connected to a subnet, and then 192.168.1 and 192.168.2. Basically the same exact thing. All right, so network 192.168, if I can type, 168.0.0, and then 0.0.255.255, allowing everything in those in that /16 space. And that's area 0. And then the same network for the serial subnet 203.0.113.0. That's going to be 0.0.0.255, area 0. Okay, now that should be all configured. So I want to see if we can now, first of all, check the routes on R1, for example. And it looks like we've got some neighbor relationships forming for OSPF, so that's good. So we can say do show IP neighbor, do show OSPF neighbor. All right, well, that didn't work. Let me go back. Show IP OS neighbor. Yeah, why didn't that work a second ago? Do show, IP OSPF neighbor. All right, so there's a neighbor relationship happening there. I think that's good. Show IP route, if I can type. So router 1 has now learned routes via OSPF to 192.168.1 and 192.168.2 via 203.113.2, which is over here across the serial link. And so yeah, that looks good. That means these PCs now have routes to these PCs in the 192.168. And just to check the other side, do show IP OSPF neighbor, and there's a neighbor relationship here as well. So let me do show IP route, and again router 2 has learned via OSPF routes to the 172.16.1 and 172.16.2 via 203.0.113.1, so this R1 interface here. And so any traffic from this side of the equation will be sent to get routed on R1 at its S000 interface, and then the routes to the subnets that are attached elsewhere on R1, can receive packets. Okay, so I think that's good. So now let's just ping. First of all, let's ping again from PC 1 to server 1, and let's see if we have connectivity there. Let's make sure that works first. Request timed out, and then we've got some success requests. So the ARP process takes place, we lose a couple packets, or one in this case, and then we get successful pings, unlike what we did earlier up here. And now I would expect all 4 to happen a bit more quickly because the ARP process is already complete. So 4 sent, 4 received, 0 lost. All right, so we know we have connectivity from PC1, for example, over to the 192.168.2 subnet. So now I believe it looks like we're going to start filtering some traffic. So this is the new stuff. Okay, so number 2, configure standard numbered ACLs on R1 and standard named ACLs on R2 to fulfill the following network policies. Only PC1 and PC3 can access 192.168.1.0/24. Hosts in 172.16.2.0/24 can't access whatever. 172 can't access, 172 can't access. Okay, so first things first, this one, only PC1 and PC3 can access 192.168.1.0. All right, so first of all, 192.168.1.0 is on this side of things, okay? And therefore, and the next one, 192.168.2.0. So the first thing I like to do is isolate the part of the network that we're talking about, because with these, you want to configure the ACL as close as possible to the affected subnet. And so in this particular one, PC1 and PC3 can access 192.168.1.0. That's right here, 192.168.1.0. It's connected to the G00 interface of R2. So we're going to want to apply the ACL outbound on the G00 interface so that traffic coming into R2 and then designated to go out of G00 to 192.168.1. whatever is filtered by this first ACL. And it can read the ACL and say like, oh, okay, PC1 and PC3, and if not anything else, blah, 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 then you're not allowed. All right, so first things first, we're gonna need to create the 2 ACLs on router 2 and then assign them to the appropriate interface on router 2 and give them the appropriate direction. And both of them, I believe in this case, are going to be out on router 2's G00 and G01 interfaces. So first things first, we need to create them. All right, so first of all, I think we want to be in configuration mode. And so the rule says, or the instructions, I should say, rule is kind of an overloaded term here. Configure standard ACLs on R1 and standard named ACLs on R2. So we're working with R2 clearly. We want to do named ACLs. I feel like, see if I can remember the syntax for this. So I think it's IP access list standard. Okay, then we give it a name. So if we're doing the one in the Jeremy IT Labs, like the instructional video, he like says 2 underscore and then the actual full subnet. So I guess I can just match that. I assume that's how you would want to do it in the wild. So it's just very clear what this ACL is doing. So IP access list standard 2 underscore, and this is going out to 192.168.1.0/24. So 192.168.1.0/24. Like that's all the name. All right, so if I press enter, we are now in a standard network access list configuration mode. And what do we have in here? Okay, so now we can start permitting or denying or adding remarks or etc. And in fact, we can do custom sequence numbers, although I don't think we need to do that here. But if we want to control the way or the order in which, if we want to have more granular control over how the router interprets the access list, interprets the ACEs in the access list, we can, using these named access lists, we can apply custom sequence numbers. With the unnamed ones, I think they're just default by tens. We could confirm that in a minute. But anyway, only PC1 and PC3 can access. All right, so we want to say, I think we want to say permit. Now only PC1. So PC1's IP address is 172.16.1.1. So permit, and then what is it? We want to do a host, a single host, and its address. And so this is a kind of a shorthand way to limit access to a single /32. So I'll do it like this for this first one. 172.16.1.1. All right. So we've permitted a single host. Now there's another way. There are actually, I think, multiple ways, but another way to do it is to write out the full wildcard mask to be a /32. So let's try that on the next one. So PC3. All right, so PC3's address is 172.16.2.1. So we're going to say permit 172.16.2.1 and give it a wildcard mask of only that address and nothing else. All right, I think that works. All right, and now we have created the, and then we need to deny everything else. And that is going to happen by default. But we can be explicit about it so that somebody interpreting our ACL doesn't get tripped up and not realize that no other traffic will be able to come through here. So we can say deny any. So when the ACL gets interpreted by the router after we apply it to the interface, any traffic coming in, it will read the first line and say, oh, are you host PC1? Okay, no. Are you host PC2? Okay, no. And then everything else is going to get dropped. So the only traffic that can come through is from PC1 or PC3. I think I may have said PC2 a second ago. All right, so deny any. All right, now let's see if this works. So now we need to go into interface G00. So we're going to say interface G00. All right, and then I think we need to say IP access group. Now that's different than access list. It's a little tricky. It's something you just have to remember. So IP access group, specify access control for packets. All right, so access group, then I assume it wants the name. And remember, we configured it to have name this. Copy. Paste. All right, so I'll get rid of these extra erroneous spaces. All right, so we got the name there. Then what? And then we want this to be out. So everything's going to come into the router, and anything going out of the G00 interface is going to be filtered by this IP access list that says only PC1 and PC3 can reach through here to the 192.168.1 subnet. Out. All right, now that is that. So let's see if it works. First of all, I want to get out of this. Let me get out of that too. Show access lists. So we've got one access list, a named standard access list called to 192.168.1.0/24 that permits host 192. Oh, doesn't seem right, does it? And then it permits any. That is incorrect also. Okay, well, now I need to figure out how do I edit this, because it doesn't seem correct that it only permits 1.1 but not 16.2. It's instead showing any. What did I write up here? Permit host, okay, and then, oh, you know what? I bet this is wrong. So this is good debugging. So this is the wildcard to allow everything, and it should be all zeros to allow only this. So how do we edit? Let's see if I can just figure it out instead of actually Googling it, because I'm not actually sure. So first of all, we got to go to conft, and then we'll do IP access list, and then we'll give it the name again. Can I just paste? Yes. And okay. So now I'm just going to Google how to edit an existing named ACL standard Cisco iOS. To edit an existing named standard ACL, you can use sequence numbers to identify and modify lines within the list. You can add. Okay, so conft IP access list standard and then the name. All right, so I just missed one command here. IP access list standard and then the name. Okay, so we are in the configuration mode, or in the, oh, I see. Okay. So let's say we can do no 10, but we want 10. So let's say no 20, no 30. And that should only leave 10 remaining. Let's see if that, we say do show access list, what is it? Paste. And that only permits host 172.168.1.10. Okay, so now we are back in edit mode. So let's do another one where we, so we need to say permit, again for PC3, 172.16.2.1. And this time we're going to say 0.0.0.0.0, which is the wildcard to correctly limit everything. It's the opposite of, I think that's right. Let's see what it does now. All right, so 172.162.1. Okay, it only permits a single host, 172.162.1. All right, and then we're going to say deny all to be explicit about the implicit deny that it would occur normally. What is now going on? Let's see. Deny, not all, deny any. And then show me the access list. Okay, so that is what we want. All right, and now we have already applied it to the outbound on the G00 interface, which we did right here, interface G00 outbound. All right, and so I don't think we would need to apply it again, but let's see if we need to because it changed. Interface G00, IP access group, then this thing, paste, and out. All right, now let's see if we can ping server 1 using PC 1 and then verify that we cannot ping server 1 using PC 2. Okay, so let's try to ping server 1. Remember, this is PC 1. So ping 192.168.1.100 from PC 1. This, I think, should be allowed. So we've got to do some ARP resolution, and then we get a success. So we can ping server 1 from PC 1. Now, I would expect us not to be able to ping server 1 from PC 2. So let's do ping 192.168.1.100. destination host unreachable. So all these packets are going to get dropped because our ACL is instructing the router to drop them. So that's pretty awesome. Okay, so the first one looks like it's done. Next one, host in 172.162.0/24 cannot access. Okay, so everything in some subnet cannot access some other subnet connected to our G01 interface on our router, and everything else should be able to. So let's do that. So we need to create another ACL to apply to this G01 interface. Let's get back to there to config. So IP access list standard, a name. This is going to be similarly named to underscore 192.168.2.0/24. And anything else after that? No. All right, so we are now in access list configuration mode. And we need to say, we're going to deny anything in 172.16.2.0, and it's /24. So that's going to be O.0.0.255. I think that's right, and I just want to double check. Wildcard mask for /24 is at 0.0.0.255. Okay, they're easy to get mixed up. All right, and then anything else? No. So we're denying everything in 172.162.0/24. Cannot access 192.168.2.0. All right, so we're denying everything from there, and then we're going to permit basically everything else. Okay. And now we are going to apply that outbound on the G01 interface of R2. So let's go ahead and do that because that's the closest point to the affected subnet that we were trying to filter traffic into, yeah, which is kind of odd because we're calling it outbound, but it's out on this G01 interface. So anyway, interface G0/1. IP access group, our name, and it's going to be out. All right, that's done. So now let's confirm. Anything in 172, all right, so anything in 172.162 cannot access switch or server 2, for example. So let's try PC4. So from PC4, we should not be able to ping server 2 on the 192.168.2.0 subnet. Ping 192.168.2.100. Host is unreachable because our router is dropping the packets at this point, at the G01 exit point. But other things should be able to ping it. For example, let's try from maybe server 1 to server 2. Config, desktop, command prompt, ping 192.168.2.100. Now we do ARP resolution, and I would expect this to work in a moment. But it is not. Let's see. Okay. All right, that did not work. I'm curious. Let's see if PC1, 172.162.0, so let's do PC1 here. Can you reach server 2, 2.100? Yeah, so why can't server 1 reach server 2? They're on the same router? Does that make sense? Why can't server 1 reach server 2? Do show IP route. So is there a route from here, 192.168.1.0? It's directly connected. Yeah, okay. 192.168.2.0/24 is connected. So it has a route. Can 192.168.2 or server 1 ping, can server 2 ping server 1? Ping 192.168.1.100. Oh, wait a minute. Oh, that's why. There's already an ACL on it. Only PC1 and PC3, the one we did before, can access 192.168.1.0, which is up here. All right, so we already are filtering any other traffic to this server 1. Okay, so that was a little confusing for a second, but that makes sense. We configured it to work this way. Okay, now 172.161.0 can't access 172.162.0. All right, so 172.162.0 and 1.0, that's going to be on router 1. And remember, the original instruction was for router 1, we're going to use standard numbered ACLs. So let's get back into router 1. enconf access list 1. All right, and I think from here we'll go into configuration mode. No? Okay, so I think we just do them in lines like this. So first of all, so let's say we're going to apply this going out to the G01 interface to the 172.168.2. So deny and then a specific address, or we can just use the host keyword. Deny host 172.1. Oh no, it's not a host. It's a full subnet. So deny 172.168.1.0, and that's O.O.O.O.255. So 172.161.0/24 can't access 172.162.0. All right, and then we will do it again, but we're going to say then after that, permit anything else. Permit question mark, any, right? Because only stuff from that 172.168.1 subnet cannot access. All right, and then I think we just need to go to interface configuration mode, G01, and then we need to say IP access group 1, question mark, 1, yes, applied out of G01. All right, and then we need to create another one for the next instruction here, the next rule. So we're going to say exit out of this, exit out of, yeah, okay, so we'll say access list 2. We're going to deny anything from 172.16.2.0/24 We're going to permit anything else. Access list 2, permit any. And then we're going to go into the interface G00, and we're going to say IP access group, question mark, 2, out. And that will deny any traffic from 172.162.0/24 from accessing 172.16.1 G00. Okay, we are on the G00 interface and we're going outbound. All right, and let's just test that a bit. Okay, so first of all, do show access lists. So we've got access list 1 that's denying 172.161.0 and allowing anything, 172.2.0 and allowing anything. So hosts in 172.161.0 over here, so for example, PC1 can't access PC3. Let's try that. PC1 should not be able to ping PC3, which is 172.16.2.1. Host unreachable. All right, and and then hosts in 172.162.0 should not be able to access 1.0. So let's try PC4 to PC2, basically going the other way. And a ping goes both directions, so it's kind of implicitly already proven. Maybe not. PC4 is going to try to ping PC2, and we would expect it not to be able to. Ping 172.1.6.1.2. PC4 to PC2. All right, and that is unsuccessful. So I think that is all. Yeah, these are interesting. They're fun to sort of decipher and try to figure out. And, up to this point, we've worked on building these kind of small networks and with the different protocols and stuff involved. But now we're managing and filtering the traffic in ways so that, we can keep different parts of our network secure where, maybe we don't want the admin area of our network to be accessible from the internet or from other private parts of our network, etc. Anyway, thanks for joining today. I should be back maybe 1 or 2 more times this week. Would like to get into some more subnet practice, maybe some more Python, and I'm prepping videos for some drone stuff. So almost to that point, and yeah, I hope everybody enjoyed, and leave a comment if you spotted anything that could be more efficient or that you thought was interesting. Have a good day. Thank you.